All right, so I want to show you 3 ways that the AP test has been testing this idea about 2 proportion z-test or intervals. All right, so these are the types of questions you will see on the test next week. All right, so it's kind of prepping us for that. Now, number 6, if you had a chance to read number 6, this is actually asking about something we talked about yesterday for the very first time. This is about pooling. All right, so by Jarvis making that noise and everyone else with your face, I can tell you did not know that this was pooling. Let's see if you got it right anyway. So the way you want to do this is you want to imagine that there's no difference between the males and the females and how often they brush their teeth twice a day. Okay? So if there's no difference, how many total males and females am I going to put in the denominator? 210 plus 228. So that's going to be my denominator. Okay? In the numerator, how many males say that they brush their teeth at least twice a day? And then how many females? So that's going to go in the numerator. All right, so if you add those together and then divide, let's see what they are when we add them together. Get 282. Thank you. And I think you get like 0.64 something. 644. All right, so what is the proportion of all of these teenagers that are brushing their teeth at least twice a day? 64.4%. Okay, so now it says if that's the case, right, if there's no difference, how many males and how many females in the sample would you expect to brush their teeth at least twice a day? So you take this 0.644 and you multiply it by the number of females and the number of males. So how many males? 210. How many females? 228. If you do that, you will get your answer. So this one is 135. And the females, 147. So it's C. I don't know. What is it say? Great. Is that what it says? You got it right? Got it.
In bold.
Bold. All right, but again, this question, whether you got it right or not, is about pooling. All right, that idea that if you're doing a two proportion z-test, we first are assuming that there's no difference between the groups. So that's why we pool. All right? Everybody good? Okay, let's go to the next one. Number 40. Now, number 40 required the computer to actually get this right, but without guessing. All right? So this one is asking me to run a test. All right? So what I'm going to do is I'm going to use the link that we used yesterday, the two proportion z-test. So that was the first email, Edgar, that I sent you yesterday. Two proportion z-test. Okay, what is our null hypothesis always going to be? Equals. Let's look at the problem. It says in the problem, is there convincing statistical evidence of a difference between these two? So does that tell me about one being higher or lower? No, it just says, are they different? So for the alternative, I'm going to use not equal to. Okay, let's go back here. What is the sample size for my first group? Very good. 230 residents with school-age children. So I'm going to type in 230. Out of those 230, how many said that they'd be opposed to banning the trans fats? 94. Okay. How many in the second group that they asked? 341. Very good. And how many said that they would be opposed to the ban? 147. And the last thing is, it says in the problem, what significance level, what alpha? 0.05. All right, so if you do that, hit solve, and then count to 26. $26! Wow! Oh man. Those people at home listening could hear me whispering that. Okay. Now, really this question, because it's multiple choice, all right, it's asking me to determine rejecting or fail to reject a null. All I care about is the p-value. So I went to the very bottom. What is my p-value? 0.5952. So my p-value, 0.5952. And the moment I read that, 0.5952, comparing to 0.05, do you see how that is much higher than 0.05?
Yeah.
Right? So because that p-value is so big, do I have enough evidence to say that there's a difference in these proportions? I do not. So the moment I read yes, 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 I cross them out. So I know the answer is going to say no. There is not convincing statistical evidence of a difference between these two proportions. But the question is it D or E? So when you read it, you'll notice our decision was made because our p-value is above alpha. So when you read E, it says no because the probability of observing, that's the p-value, is less than 0.05. That's incorrect. It's because it's greater than 0.05. So at least you would have gotten to 50-50 if you understood that we're rejecting. Okay? Okay. All right. Okay. Sounds good. All right, the last one. Now, there are a couple of ways to go about doing this last one. Okay? I'm going to show you the way that my brain approaches this. If this doesn't work for you, you can do it your way, that's fine. All right, but the first thing I do is I try to look for things that I know are wrong right away. Okay? And because it says a 99% confidence interval, I know A is wrong right away. Because if you look at answer choice A, you'll see that the z-star they use is 1.96. 1.96 is for a 95% confidence interval. So the moment I read A, I don't even look at anything else. I know that A is going to be wrong. So the first thing I do is I go to the critical values, because I know that the critical values are different. So I know that some of them will be wrong because of that. Now, I couldn't really eliminate B, C, D, or E because I don't know the 99% z-star. All right, so I'm going to leave those alone for now. I'm going to show you how to do it in the computer. Now, when you look at D and E, do you see how D and E do not look like anything in the standard error? Do you see these standard errors here? Those standard errors do not look like anything we've been doing, so those are wrong. You gonna be okay? All right, because again, hopefully you guessed right if you didn't actually calculate. Now, if you look at B and C, you'll notice that the answer choices are identical except for z-star. Right? They have the exact same standard error, the exact same difference in the proportions. So to calculate this, you actually have to go to an email I sent you on January 9th. And what I decided when I was going through this is that for the test next week, I'm going to post on Classroom the links in one spot, so that way you can just go and open them all at the same time. Yeah. Next Thursday, a week from tomorrow. All right, so if you go to an email I sent you on January 9th, I believe it, let me confirm that it's the 9th. Yes, the 9th. January 9th, I sent you an email that says z-score calculator. All right? Now, this calculator, we used a bunch to calculate the area under the curve. All right, but to use for this problem, we're actually going to use the second part of this calculator, which says inverse normal distribution. All right, the second one. So I'm going to do a little writing here, and this is what kind of separates. This is one of those questions when I used to read analysis of multiple choice for AP tests. This would be a question that would differentiate kids from a 4 and a 5. Okay? So if you draw a curve, I did teach you this. Am I not allowed to teach you again? Okay. So what level of confidence are we using for this problem? 99%. So that means how much is in each tail? 0.5%. So if it's not as a percentage, it's as a decimal, you'd write 0.005. Okay? So you have two options. In the decimals calculator, you can type in 0.005, or you could type in 0.995. Either of these would work. This first one would give you the negative z star, and the second one would give you a positive, but it'd be the same number. So it's up to you how you want to decide. All right, just remember when you type into this function, it's going to give you the z star with that amount of percentage to the left of it. Okay, so this one would be our negative z star, and this one is our positive z star. Okay, so I decided what I've always done is I always just plug in the one that's the negative one, the 0.005. So if you go where it says 0.1586 and type in 0.005, you'll see our z star is 2.576. Our z star is 2.576. Sorry, Jeremy. So it's C. All right.